Hi, this is Charles Warburton, and this is the introduction video for Math 85, Module 1. And before we jump into the material for Module 1, I think it's important to talk a little bit about why algebra is so important to study. And it seems like algebra gets more attention than other fields of study like geometry or even statistics. And that's because the vast majority of the values that you deal with on a day-to-day basis are values that change. In other words, like the money in your bank account, that changes, your age changes, the speed of your car changes, your attention span to this video changes. All these values change. And that's what algebra looks to study. It looks to study how values change. And because they change, that means that they vary. That's why they're called variables. So variables are usually represented just by a letter. Like if my bank account changes and it's a variable, maybe we could just call it X. But I think that we can do a better job than just saying that if a variable varies, we call it some generic letter. A lot of times what we do with variables is we can express them better with expressions. And expressions are very important. They're the cornerstone of lots of different things in algebra. So let's consider the expression that expresses a cell phone bill. Like maybe a typical cell phone bill will charge you $50 plus 10 cents for every minute you go over, but you don't know how many minutes you're going to go over. That's a variable, so it's 10 cents times this unknown, x, where x is the number of minutes you go over. We'll just make a quick little note. Number of minutes over. This expression expresses your cell phone bill. So my cell phone bill changes, but we can do a better job than just saying my cell phone bill changes, so it's a variable, so I'll call it C. And we can do a better job. We can express it with this type of expression. What that leads us to then are equations and inequalities. Equations and inequalities compare two expressions. So you can see we have our cell phone bill expression again, and it's on the left side of the equal sign. And then we have another expression on the right side of the equal sign, and this expression on the right side of the equal sign expresses another cell phone bill. So what this equation does, I know it's an equation because of the equal sign in the middle, it asks the question, when is the cell phone bill on the left the same as the cell phone bill on the right? And I guess it depends on the number of minutes you go over, because here they charge us less up front but more per minute, and over here they charge us more up front and less per minute. So in Module 1 you'll have to figure out what value of x makes this true, and you'll learn how to do that in this module. Also, you can compare two expressions by using an inequality, and I think in this case it makes sense. Maybe you want to know when the cell phone bill on the left is more than or greater than the cell phone bill on the right. Let's see if I can get this to work here. So greater than, with the greater than symbol, that asks the question, when is the expression on the left greater than the cell phone bill on the right? And then you can do a similar process to find that answer. Okay, so you'll learn how to do these things in the first module. Another thing you'll learn how to do in the first module is to work with equations with two variables. And usually what happens is if you have two variables, one variable is the variable that you're allowed to plug in any value you want. Now, remember, back here you can't plug in any value you want because not all values make the expression on the left more than the expressions on the right. But here, equations with two variables, you get to choose what value you want to input for x. And then once you input it, then you can input and then do the order of operations. Like for example, maybe I would input an x value of 0, And then I have to do the order of operations, which says to multiply first. 10 cents times 0 is 0. And then I can add. And then that gives me the result of plugging in an x value of 0. This is called the output. The output is the result. So when you have two variables, one variable is the value that you input, and the other variable, generically y, is the output. So one way that we can notate that is with an ordered pair. And the ordered pair says I input 0, and as a result I output 50. This is called an ordered pair because it alphabetically orders the input x and the output y. This is ordered pairs. Okay, so then what we can do is we can take our ordered pairs and put them on a graph. Remember, my ordered pair was 0, 50, which tells me my x value goes over 0 units on the x line. So here's my x line. I'm going to go over 0, but I'm not going to stop because now I got to do what the y value tells me to do. I'm not going to put a point on the x value of 0 because now I got to go up 50, and now I'll put a point right there. I went over none and up 50. That black dot is the corresponding point to that ordered pair. And then I can find another ordered pair. Let me go back and maybe find another ordered pair. I'm going to erase some so I have some room to do another ordered pair. Maybe I will plug in, I'll plug in anything I want. I'll plug in a 50 this time. I don't know why I picked 50, I just did. So I'm going to input an x value of 50. So here's my expression, $50 plus 10 cents for every minute I choose to input an x value of 50. Let's see what happens. Order of operations, 10 cents times 50 is 5. The output is $55. If I go 50 minutes over the limit, then I am going to be charged, if I go 50 minutes over the limit, I'm going to be charged $55. So now I can put that on my graph as well. The graph shows all the inputs. What did I say to do? I said to input 50 and then out comes 55. We saw that in the previous slide. On the x line, go over 50. On the y direction, go up 55. About right there. And these graphs will be linear, so I can draw a straight line through there. We'll see why they're linear later on in the course, but now I have a straight line through those 2 points. So what we can do then is we can see the input and output for the 2 different scenarios based on what I chose to plug in for x and then what I got out as a y. And now you can see that the graph is a picture of all of the xy values, even the xy values that I didn't choose to plug in. They're on that line. And it gives us kind of a broader picture of what the y values are doing. The y values are going up. You can see they're going up. And I guess the question is, how fast is my cell phone bill going up? And in Module 1, that's what you'll be studying. You'll be studying how fast a graph increases or decreases using something called the slope. The slope tells you how fast the y values increase or decrease based on a set of ordered pairs or a graph. But the slope is notated by the letter m because you can kind of see from the graph this almost looks like the side of a mountain, right? So m for mountain, you want to see how fast that mountain increases. Well, you got to see how fast your y values increase first, and you can see that the y values increased by 5. Okay, and I guess one way you could do that is by subtracting the y values. And that will show you that they're increasing by 5. And then see how fast the x values increased. Also subtract those in the same order. My x values increased by 50. So that tells me for every 50 minutes that I go over, they're going to charge me $5, but I can reduce that fraction to 1/10. They'll charge me $1 for every 10 minutes I go over, or maybe even as a decimal. That tells me I am charged 10 cents for every minute. That's my slope. So how we can find the slope then is by taking my two y values and subtracting them, and then dividing that by the corresponding x values and subtracting it. But you may have noticed that in the equation, my slope was actually just right in front of my x value. Let's go back and take a look. Remember, my slope was 10 cents a minute. Go back to the equation. Oh, there it is. There's my slope right in front of my x. So sometimes if they give you the equation, you don't have to go through the big formula here to find the slope. That's how you find the slope if they don't give you the equation. But if they do give you the equation, just look at the number right in front of x. That will tell you the slope. You don't have to do any fancy mathematics. So what that tells you then is, sometimes we can write an equation of the line just by some of the information that they give us. If we know the equation of the line is the y value is equal to the slope times the x value plus this other value, which happens to be the y-intercept, where it hits the y line. So here we have the slope, and here it's where it hits the y line, called the y-intercept. Then we can actually write an equation of a line. If we can find the slope, you guys know how to do that, and if you can find the y-intercept. Sometimes the y-intercept is just a matter of looking at where the graph hits the y line. Other times you might have to do a little bit more work. You'll see how to do that in the first module. Okay, so hopefully this first module will be a nice study of getting used to how algebra helps us express variables in a better way using expressions, and how you can compare expressions with equations and inequalities. That's how we can compare two expressions. And sometimes you want to plug lots of values into expressions by using equations with two variables that look like this. Y equals some expression. And if you're going to plug in lots of different values, then you're going to have to organize your values using a t-chart, and that t-chart will get you some ordered pairs, and those ordered pairs will ultimately lead to a graph. And that graph can be analyzed, can be described by the slope. Okay, so I hope you enjoy studying these concepts in Module 1.